Hello friends, today we'll derive the equation which is equivalent self-inductance of a group of a cell of a coil. Okay, cells, if cell is connected in series and if cell is connected in parallel. Okay, so we'll derive these two both in a same video. So let's go. Okay, so we know that the is EMF is equal to uh, this minus del by phi by dt, change in flux, difference in the change in flux in the change in time. Okay, so this is a flux, this is a induced EMF formula. Okay, we know that the phi is equal to Li. Okay, L is the inductance and I is the current. So if we put here in the phi this and will be differentiated, so it will become minus L d by it. Okay, it will become this. Now what we'll do from here, we're seeing the diagram. So this is the inductance L1 and this is the inductance L2. So what we'll do, we'll take the EMF which is equal to the I1, E1 and E2. Okay, this is the EMF. Okay, so for E we have this. So for E1 we will have minus Li1 di by dt, because the current is same. Okay, the current is I here, so current is the constant in each of them, and this, and secondly E2 is equal to minus L di by dt. So this is the second. Put E1 and E2 values here and E values here. So L is become to this minus di by dt plus, not it is minus L di by dt. Okay, so now take the minus as a common. Okay, here is the I1 and here is the I2. Okay, so take the minus and di by dt is the common, so it will become L1 plus L2. Okay, it will become the L1 and L2. Now what you need to do, cancel the minus sign, cancel the di by dt in the both. Okay, and you left L from here and L1 plus L2. So it is proved. Okay, now we will go to derive the cells. If the cells connected in parallel. Okay, if the cells connected in parallel, so we can say if we pass the current I from A to B, so it will divide, the current will divide in I1 and I2. Okay, the current will divide in respectively L1 and L2. Okay, so if these are in parallel, so current is going to I plus I equal to I1 plus I2. Okay, so this is a current which is equal to I1 plus I2. Now what we'll do, we should know the I value. So E is equal to what? Minus L di by dt. Okay, so from here we can say di by dt is equal to E by minus L. So this is equal to our first equation, and for E1 and E2 you to take the separately. Okay, so and the current is I. If we are taking the di1 divided by d2, dt is equal to minus E by L1. Take it as the equation 2. And if we are taking similarly we are taking it. Okay, and di2 by dt is equal to minus E by L2. This will be our third equation. Put one equation in here and here, so we can't put it here. Okay, we should differentiate with respect to the time. So while we are differentiating with respect to the time, it will become, okay, now put the value here. Okay, in di by dt is equal to this, and di first is equal to dt is equal to this and this. So put 1 2 3 in the respective form. So we'll get minus li equal to minus el I minus el2. Now what you will do, you will take the minus e common, so it will left li plus this is gonna left. Now cancel the e and the minus sign, we're left with this. Okay, and this is it. Thank you for watching it. It is proved when the cell is connected in parallel. Okay, this has happened.